Welcome back to Chapter 20, Part 3, where we're going to be doing more examples. We have two independent samples. 55 out of a random sample of 100 students at one university are commuters. 80 out of a random sample of 200 students at another university are commuters. We wish to test the claim that the proportion of commuters at the two universities differs at a 0.05 significance level. Well, the first thing we have to do is we have to check our assumptions. Now, we have simple random samples, and let's look at the counts of successes and failures. Well, in both of these, there are at least 10, so we can do the normal approximation for both confidence intervals and hypothesis testing. So, first, let's construct our null and alternative hypothesis. Well, we assume in our null that the proportions are equal, and we were looking at a 0.05 significance level whether the proportion of commuters differs. So, in order to calculate, our next step would be to say what our alpha is. It's 0.05. And now we can try to calculate the test statistic. Well, first, we have to, since we're assuming that P1 equal P2, we have to find our pooled statistic. So we say 55 plus 80, that's the number of commuters in sample 1 plus the number of commuters in sample 2, divided by the sample size, N1 and N2, which is 100 plus 200. So we get our pooled statistic as 0.45. So in order to calculate our test statistic, we need that. So we put our numbers in, and we get that our test statistic is 2.46. This has an approximate standard normal distribution, so we can find our p-value. It's going to be 2 times the probability that z is greater than 2.46. So it's 2 times 1 minus 0.9931, or you could have used symmetry. So we find out that our p-value is 0.0138. That is less than our alpha, so we're going to reject. So there's sufficient evidence at a 0.05 significance level to support the claim that the proportion of commuters in the one college differs from the proportion of commuters in the other college. Now here's how we could use Minitab to help us to calculate this. The command would be P2, and again we put our N1, X1, N2, X2, so that'd be 100, 55, 280. The alternative is 0 because this is a two-tailed test. Now we've got to let it know that we're doing a pooled hypothesis test. And if we wanted to, we could also do a 95% confidence interval to get a confidence interval if we so desired. And what would come out when we hit enter is we'd get our sample size along with our number of successes, and then we'd actually see our P1 hat and P2 hat. And then it would tell us what our 95% confidence interval is. And after that, we'd see what our test statistic, 2.46, the p-value 0.014. And those are very similar to what we calculated ourselves. Let's take a look at example 2. Last year, the Gallup organization surveyed 120 adults aged 18 or older and asked, do you think there is life with some form on other planets in the universe? Of that sample, 73 responded yes. When the same question was asked 3 years earlier, 86 of a different sample of 120 individual surveys responded yes. We want to test the claim that the proportion of adults who believe that there is life on other planets has decreased during the 3-year interval at a 0.1 significance level. So let's answer some questions. When comparing two proportions from two populations or two treatments, what is the parameter of interest? What would you say? Well, I hope you picked A, P1 minus P2. Let's look at question number 2. The purpose of a confidence interval comparing two proportions from two populations or two treatments is to give the range of reasonable values for which one, A, B, C, D, or E? P1, the difference between P1 and P2. So D. So for the sampling distribution of the differences of the two sample proportions, what is the mean of that sampling distribution? C. What is the shape of the sampling distribution of P1 hat minus P2 hat when all the conditions are met? Well, it's approximately normal. Now we're going to go back to the survey example number 2 and answer this question. So what I did is I went into Minitab and I put our data in, and this is the result. We get a p-value of 0.04, which is much less than 0.10. So there is, at a 0.1 significance level, there is sufficient evidence to support the claim that the people who believe that there are life on other planets has decreased during the 3-year interval. Now let's look at our last example for sampling distribution. Suppose that you take a simple random sample of 1,000 Pennsylvania students, P1, eligible to take the SAT, and find that 75% plan to take the SAT during 2004-2005 school year. You also take a simple random sample of 1,000 Rhode Island students, that's our second population, and eligible to take the SAT, and find that 76 of those plan to take the SAT during the 2004-2005 school year. What is the mean of the sampling distribution P1 hat minus P2 hat under the null hypothesis? That means that P1 equal P2. Well, if P1 equal P2, that means that P1 minus P2 equals 0. And if P1 hat minus P2 hat in the sampling distribution equals P1 minus P2, well, then that would mean that the mean of the sampling distribution under the null hypothesis is 0. Hope everybody picked E. Now let's look at another question. Suppose we want to test whether the proportions from the two different populations are significantly different from one another. What would be the appropriate null and alternative hypothesis? Very good if you picked A. And number 2, what do you use? When do you use the pooled sample proportion? You use it when doing a significance test, because that's where we assume that P1 equal P2. If you calculate a 95% confidence interval for the difference in the proportion of eligible students in Pennsylvania and Rhode Island that plan to take the SAT during the 2004-2005 school year, and you end up getting negative 0.048 to 0.028, what is your conclusion to this two-sided test with the null hypothesis P1 equal P2? In other words, is the test statistically significant? Well, zeros in that interval at a 95% confidence interval, so that means that at a 0.05 level of significance, the two-sided test would be statistically significant. So yes, because 0 is included in the interval. Well, that concludes part 3. In part 4, it's short, but it will be it's going to be a review of all the confidence intervals and tests of significance.